Welcome to Voyage Daily Tech, the most important news personalized for you every day, supported by Voyage.com.
After listening to today's news, you'll know. First, OpenAI's 6 gigawatt AMD GPU deal challenges Nvidia's dominance, signaling a viable CUDA alternative. We'll analyze why this dual sourcing strategy is a turning point and how it could affect competitive dynamics in the AI chip market. Second, Nvidia's CEO admits China is nanoseconds behind in chip development as domestic rivals challenge CUDA's dominance. We'll explore how this tech race could transform global supply chains and what it means for the future of semiconductor manufacturing. Third, $1 billion federal loan resurrects a nuclear plant to power AI, marking a historic US energy policy shift. So we'll discuss why this unprecedented move matters and what it means for the future of energy infrastructure and public-private power competition. Fourth, UK pivots agricultural AI for national security wargames, a £1 million bet on lean defence innovation. In this episode, we'll break down how supply chain optimization logic is being repurposed and what it signals for the future of AI in military strategy. Fifth, Amazon and Meta unite to create a market for sustainable concrete, tackling the 8% of global emissions from their data center builds. We'll analyze why this demand-side alliance is a turning point and how its book and claim model could affect the scaling of green materials. A single deal just sent AMD stock rocketing up more than 35%. The reason? OpenAI, the maker of ChatGPT, has struck a deal that could give it a 10% ownership stake in the chip maker. We previously analysed how platforms and governments worry about concentration risk when any single supplier dominates this move, fits that diversification playbook perfectly. Now, get this. As part of the tie-up, OpenAI will deploy a massive 6 gigawatts of AMD's GPUs over several years. The deal is worth billions, but the real story is the power play this represents. A while back, we talked about the rumoured $500 billion Stargate memory build-out. Today's update is the compute side complement locking in GPU capacity and the power to run it. And to really grasp the scale here, 6 gigawatts is enough electricity to power roughly 4.5 million US homes for a year. This shows that the biggest bottleneck in AI is no longer just the supply of chips. It's the staggering amount of electrical power needed to run them. We're talking about a level of energy consumption that challenges national power grids. Data centers could consume up to 9% of all US electricity by 2030, and this deal is a huge part of that. That's where those microfluidic cooling ideas we talked about start to matter, especially as mega sites run into power and water constraints. This move is a direct challenge to the undisputed king of AI chips, Nvidia, whose shares actually fell on the news. We recently noted Nvidia widening its moat by pairing some GPU designs with Intel's factories. This announcement pressures that moat from the demand side. However, if you zoom out, you'll see another layer of strategy at play. Nvidia's dominance isn't just about its hardware, it's built on a powerful software ecosystem called CUDA. For years, almost all serious AI development was locked into CUDA. But AMD has been quietly building its own alternative, an open source platform called ROCm. By making this massive commitment, OpenAI is signaling that AMD's software is finally ready for the big leagues, creating a real viable alternative to Nvidia for the first time at this scale. If that was just the appetizer, the main course is just being served. This partnership comes just 2 weeks after OpenAI unveiled a landmark $100 billion agreement with, you guessed it, Nvidia. OpenAI isn't just picking a supplier. It's playing the two biggest rivals against each other. A few days ago, we mentioned the broader hyperscaler push to own more of the stack. Today, the focus shifts to using supplier competition to shape those roadmaps. This is a classic business strategy known as dual sourcing, and it's a brilliant power play. By becoming a critical customer for both AMD and Nvidia, OpenAI gains immense leverage. It can negotiate better prices, reduce its dependence on any single company, and ensure it's never held hostage by its suppliers. And that ambition has a staggering price tag. Between the new AMD deal and its recent Nvidia agreement, OpenAI has now committed roughly $1 trillion in new build-out spending in just the past 2 weeks alone. That trajectory rhymes with the Stargate ambitions we discussed and the hundreds of billions in capital expenditure from Microsoft, Google, and Amazon this year. This reveals the new circular economy of AI, where capital, equity, and computing power are all traded between the same handful of companies. OpenAI needs chips, so it's buying from everyone. Chip makers need huge customers. In this case, AMD finally gets a flagship customer at the forefront of the generative AI boom. And remember, GPUs are only half the story. The SK Hynix Samsung race to deliver next-gen HBM sits underneath deals like this. So what's the big takeaway from all this? Well, this isn't just a business deal. It's accelerating the formation of an AI oligopoly. We are witnessing a consolidation of power where a few giants, OpenAI, Nvidia, AMD, Microsoft control the essential infrastructure of AI, making it incredibly difficult for smaller startups like Cerebras to compete. This deal reinforces OpenAI's transformation into one of the most aggressive infrastructure builders in the AI sector, a company willing to spend whatever it takes to secure its future. We were just talking about OpenAI creating a second source to challenge NVIDIA's dominance. Interestingly enough, that's not the only front where NVIDIA is feeling the heat. The company's own CEO just admitted that a major global rival is catching up at lightning speed. His exact words, China is just nanoseconds behind the US in chip development. Now, NVIDIA's power isn't just about having the fastest chips. The real lock-in is their software ecosystem called CUDA. For years, developers have built AI applications using it, which effectively creates a digital moat around their castle. So when we talk about China catching up, it's not just about building a faster chip, it's about building a whole new universe for developers to live in. And the competition has undeniably arrived. Chinese tech giant Alibaba announced a new chip that it claims can match the performance of NVIDIA's own processors while using less energy. But we have to add a dose of reality here. These performance claims are often self-reported. We're seeing the beginning of what some are calling a benchmark schism, where Chinese and Western AI hardware are measured by different standards. Without public benchmarks, it's very hard to independently verify these claims. At the same time, Huawei unveiled what it calls its most powerful chips ever, along with a 3-year plan to challenge NVIDIA's dominance. This is where that software moat comes back into play. Huawei's strategy isn't just about hardware. They are pushing their own software platform, Mindspore, as a direct alternative to NVIDIA's CUDA, hoping to break that lock on the market. This isn't just coming from the giants either. A relatively unknown startup, DeepSeek, sent shockwaves through the tech world by launching a ChatGPT rival so efficient, its debut temporarily sank NVIDIA's market value. This is where the situation takes a more complex turn. It seems China may not be trying to build a single chip that beats NVIDIA's absolute best. Instead, the goal might be to mass produce good enough domestic alternatives that satisfy 80% of the market's needs. DeepSeek, for example, developed its powerful AI model for a fraction of the cost. This approach could starve NVIDIA of its largest potential growth market. This is far more than a corporate battle. It's a high-stakes tech war. The US has tried to slow China down with export restrictions, but here's the great irony. Many experts believe these sanctions are having an unintended consequence. By cutting off access to top-tier US chips, the restrictions have created a protected market for domestic Chinese chip makers, forcing them to innovate faster. Now, Beijing is fighting back, launching an anti-monopoly probe directly targeting NVIDIA. The pressure is so intense that NVIDIA's own CEO is urging the US to compete for its survival. And while some experts say China still has a gap to close, one engineer's prediction puts the entire race into perspective. China might only need 5 more years to be completely independent from the US. But that 5-year timeline hinges on overcoming one massive hurdle: manufacturing. It's one thing to design a chip, but it's another thing to mass produce it using restricted technologies like EUV lithography. The race is not just in the design lab, it's on the factory floor. So the global race for AI supremacy is pushing the limits of technology and manufacturing. But there's another equally critical resource bottleneck: sheer power. And a historic decision in Michigan shows just how desperate the industry is getting. A nuclear power plant, officially decommissioned and shut down in 2022, is being brought back from the dead. The price tag to resurrect the Palisades plant, a staggering $1 billion federal loan. This isn't just about flipping a switch back on. It's the first ever restart of a closed reactor in US history. Now, public acceptance is often the biggest hurdle for nuclear projects. So why here? Why now? Well, it turns out this Michigan community has a long history with the plant, and the promise of high-paying jobs changes the entire conversation from not in my backyard to yes in my backyard. The reason for this unprecedented move is a new, insatiable demand for electricity that experts admit they didn't see coming just 5 years ago. The culprit, the massive data centers powering artificial intelligence. But that's not the whole picture. This isn't just about more power, it's about who gets it. As tech giants race to build these AI factories, they're creating a kind of private parallel energy grid. The risk is that the newest, most reliable power gets reserved for a handful of corporations, while the public is left on an aging infrastructure with higher bills. We're already seeing this play out with a recent power auction in the Mid-Atlantic, seeing prices jump 800%. One local leader said that 5 years ago, the big concern was a 20 megawatt marijuana farm. Today, that's a fraction of what a single data center demands. This energy crisis has titans like Bill Gates, Google, and Microsoft all turning to nuclear. Gates himself just declared the future of energy is subatomic. And believe it or not, this adds a whole new layer of global drama. The resurrected Michigan plant will also be home to the nation's first small modular reactors, or SMRS. Many of these advanced SMRS require a special kind of fuel called HALEU, and for years, the global market for that fuel has been dominated by one country, Russia. This creates a massive geopolitical risk. So the US is now in a race to build a secure domestic HALEU supply chain from scratch. The plan is to have two of them running by the early 2030s. But while the promise is huge, experts warn that the viability of these new reactors is based on projections, not operational evidence. To understand the risk, you just have to look at an SMR project in Idaho that was cancelled last year due to soaring cost overruns. The initial cost was projected at $3.6 billion, but by 2023, that estimate had ballooned to over $9 billion. This is the core of the first-of-a-kind gamble. Who exactly is shouldering this multi-billion-dollar risk? Critics argue these are unproven projects that could divert billions from solar and wind. Even the old Palisades plant needs major repairs. It's a high-stakes gamble, but one that more Americans are willing to take, with public support for nuclear power now at 56%. While the US is making multi-billion-dollar bets on physical infrastructure like nuclear plants to secure its future, the UK is taking a completely different and surprisingly lean approach to national security. The technology being used to predict their next crisis was originally developed for the food production industry. That's not a mistake. The UK's Ministry of Defence has awarded a £1 million contract to a consortium of universities, including Oxford and Cambridge, to run a new generation of national security war games using artificial intelligence. And while £1 million might sound like a lot in the world of AI defence spending, it's actually a lean innovation approach. When we place the UK's £1 million bet alongside the billions the US has poured into projects like Project Maven, the difference in strategy becomes clear. This UK project isn't about outspending everyone. It's a pilot, a strategic bet on being smarter and more agile. But this isn't some top secret AI built from scratch. A professor leading the project confirmed they are pivoting the immense capability developed for Lincolnshire's food industry to solve defence problems. So how does that work? How do you go from predicting potato harvest to predicting troop movements? Actually, the underlying logic is surprisingly similar. The AI built for agriculture is an expert at supply chain optimization. In essence, that same AI can be trained to model military logistics, predict an adversary's supply chain weaknesses, or forecast where they might move their assets. It's all about spotting patterns in complex systems, whether that system is food or a conflict zone. And this represents a huge shift. The goal is to get ahead of threats that are evolving faster than ever, modeling responses to terrorism, cyber attacks, and economic disruptions. Research shows these systems can be fed vast, real-world data sets from market data to shipping logs to simulate the cascading effects of a crisis. According to the university's Deputy Vice-Chancellor, the AI will be used to understand our moves and an enemy's moves to make better decisions. The challenge, though, is that making better decisions with AI isn't as simple as following a computer's suggestion. This decision brings both benefits and comes with inherent risks, which is why there's a huge focus on something called explainable AI, or XAI. The goal is to prevent a black box scenario where an AI gives an order and no one knows why. The military is building protocols where a human commander is always in the loop, able to exercise that final critical judgment. In a new era of high-stakes strategy, the United Kingdom is betting that an AI honed on agriculture can provide the decisive edge in national security. Speaking of cross-industry solutions, our final story today involves another unlikely alliance. Two of the biggest names in tech, Amazon and Meta, have joined forces with the world's largest warehouse owner, Prologis. And their target isn't software or a new device, it's concrete. So the thing is, both Amazon and Meta are in a race to build a massive global network of data centers to power the AI revolution. These are colossal, concrete-intensive structures. This alliance isn't just a PR move, it's a critical supply chain strategy to meet their own aggressive net zero goals, because you can't build the future of AI without pouring a whole lot of concrete first. Why concrete? Because its manufacturing is responsible for a staggering 8% of all global greenhouse gas emissions. The problem lies in the basic chemistry involved. To make traditional Portland cement, you have to heat limestone to incredibly high temperatures. This process called calcination literally bakes CO2 right out of the rock itself, releasing it directly into the atmosphere. For years, the industry has been trapped in a deadlock. Cement suppliers won't invest in making a cleaner product without clear demand. At the same time, large construction buyers can't find enough low-carbon concrete to buy. So now these corporate giants are forming the Sustainable Concrete Buyers Alliance, or SCOBA, to break that stalemate. Their strategy is to use their massive collective purchasing power to create and guarantee demand. This is what's known as a demand-side initiative, similar to what other groups are doing for green steel and sustainable aviation fuel. The idea is simple. If the biggest buyers in the world all agree to buy a green product, the market will have no choice but to start making it. Here's where it gets interesting. They're using an innovative system called book and claim, the same mechanism that helps scale the renewable energy market. Now, the book and claim model is both brilliant and potentially controversial because it decouples the physical product from its environmental benefit. In practice, it means a company building in New York can fund the production of low-carbon concrete in California, getting the environmental credit without the logistical nightmare of shipping concrete across the country. But there's a crucial catch. The big risk with systems like this is something called additionality. The key question is, are these purchases actually funding times, new times, green capacity, or are they just subsidizing a producer that already exists? To avoid becoming a greenwashing tool, the system needs robust verification to prove every dollar is creating a real-world reduction in carbon. This isn't just about a few green buildings, and this is where startups like Brimstone enter the picture because they're at the heart of the solution. Instead of using traditional limestone, Brimstone's technology uses a different carbon-free rock, avoiding that nasty chemical reaction. As its CEO said, it's a huge win when some of the biggest companies in the world join together to build a market for sustainable concrete. By uniting, these titans are betting they can build something far bigger than data centers. They're trying to build a new sustainable foundation for the entire global economy.
That's it for today on Voyage Daily Tech. Follow, share, and stay tuned for daily updates coming your way tomorrow.